All right, let's look at assessment. There are 5 forms of assessment. There are quizzes on the required topics. Now, the whole idea of the quizzes is, aside from allowing you to check your knowledge out, and for which I give you several attempts, so that you can check and say, oh man, I thought I knew it. And you go back and have another try. For the required topics, each topic is relevant to the tutorial of that week. And to ensure that you do actually come to tutorial knowing something about the topic, the quiz will shut at the time the tutorial starts. Alright, the tutorial starts at 6 p.m. in the evening. The quiz will close at 6 p.m. in the evening, and they will not reopen. I've had this several times, several years. People requesting that they be opened. I did one year reopen all the quizzes. It generated a lot of confusion and chaos, and essentially was not good. So now, once they're closed, they stay closed. If you've missed, you've missed. For the elective topics, they're open for all of the second half of the term, and they close off midnight on the last day of term. And that is midnight of the teaching week, not the review week. There is a team project. I briefly described that before, and there are peer reviews within that team project, and there is an exam. So let's go through each of those. Now, the quizzes, there are 6 quizzes. I think in fact there's 7 or 8, but because there's only 6 weeks in the first half of the term, then I can only reasonably examine 6 of them. The marks, each quiz is marked out of 10, and the total number of quizzes is scaled to 15. So take the average, multiply it by 1.5, and that's what your mark will be. The elective topics, they are scaled to 10 marks. Same thing, you get 3 attempts at the quiz. You can do it anytime you want, but you choose your best 2, or yeah. If you answer more than 2 quizzes on the elective topics, I will take your best 2. And they are scaled to 10. So basically you take your average mark of your best marks. The team project, I briefly described that before. There are 4 to 6 students. 4 to 6 is a reasonable number of students. That's around about what industry seems to be using as a team. I do know that some industry teams or some commercial teams run up to about 15 people, but it's starting to get unmanageable, and you're starting to get into hierarchies at that point. So I like to keep it to be between 4 and 6. Less than 4, you've got too much work to do. More than 6, there's too much danger of freeloading in the assignment, and we don't like freeloading. Each group gets to choose their own project out of a list of projects that I'll provide. Or if you don't like the list that I provided, you can come up with your own project. We'll discuss it. It can't be too small because you have to have enough substance in it to demonstrate your mastery of architecture, and it can't be too big because that would just be too demanding. It's not useful for anybody. So it has to be kind of a Goldilocks project. Now, in that project, you'll go through and you'll develop the architecture context, the conceptual architecture, the execution architecture, the implementation architecture. You'll discuss the qualities, you'll discuss what architecture pattern you've used or what should have been used. You will evaluate the architecture, and that's very important. And the report itself becomes the architecture documentation. The marking scheme for this is pretty much it's a mark out of 5 for each section of it that's relevant. And out of those 5 marks, 3 out of 5 is if you've done a competent job. That is, I can look at what you've done and say, yes, that would work, that would be commercially acceptable. Less than 3 is not commercially acceptable. To get 4 out of 5, you have to be able to describe how what you've done meets the requirements of the objectives of it. So if it's a conceptual architecture, what is the conceptual architecture required to do or to demonstrate? What have you done it for? And can you tell me how what you've done meets those objectives? Now this probably gets more important at the end of the project, where you have your finished architecture and you need to be able to say how that entire architecture achieves the requirements of it. Okay? So that'll get you 4 out of 5. And a 5 out of 5 is where you are able to explain the alternatives that you could have chosen but didn't. Now these alternatives have to be realistic alternatives. It's not a cheap mark. The realistic alternatives should be that the customer could elect to take one of the alternatives and not the one you recommended. So it has to be developed to the same depth of detail and applicability. Now the reason for these alternatives is because the customer may have described their problem at the start, and we're assuming that they actually know what the problem is, they've understood the problem, and they have clearly expressed it. We listen or read and we think we've understood it and go off and develop an architecture concern. Now neither of those assumptions are true. In the first place, the customers seldom actually understand the problem in its entirety. Frequently it is a case of when they see the answer, they then start thinking about the problem, and suddenly it's not that problem at all, it's something else. Okay? And our inability to understand what they've said is fairly famous. So we may not have understood what they've said, and they might not have done it right in the first place. The third thing that comes in is that the context of the problem has changed over time. So what we started out to solve may not be applicable anymore. It may be a different problem that we're trying to solve now, or a different architecture suits the problem as it is now. And so that's why we need the alternatives, so that we've considered it all, and we've considered what happens if we vary things a little bit. And we have these alternative architectures that might suit these variations better, and the customer now is able to choose and see that there are alternatives and to choose one. So for that, you get the extra mark. Peer reviews. Students generally don't like peer reviews. They think that somehow I ought to mark it because somehow I'm supposed to be the authority and prepared to take my word. Well, that's not true either. I have an opinion. I probably know a bit more than most of the students in the subject, but I wouldn't say I'm an expert. So the opinions of your peers are about as valid as mine. I've tested this several times, and it turns out that people mark pretty well, as much as I do, and certainly about as accurately. But the second, probably more important reason for this is that in industry, it's common practice that when you develop something, particularly where it's an architecture, you have it reviewed and critiqued by your peers. They are the ones best able to understand and appreciate and critique your work. So that's what happens. Now, they do this because they can more often spot mistakes that you haven't. And it's very embarrassing to go out to the customer and you've got some error in the thing. Or you commit heaps of money to it and you find that there's a basic flaw in it somewhere. So critiquing is a very fundamental industry practice, one that you should learn. So in this subject we will practice it. You'll practice not only presenting for a critique, but also the critiquing itself. Now, the group gets the marks that the reviewers give you. And to ensure that that mark is both reasonable and well informed, the reviewers have to give both a rating and a rationale, a justification of that rating. If they can't give a justification of that rating, that is a credible justification, then that reviewer will not receive any marks for their presentation. All right, so you get the marks for the presentation you've done. You lose them again if you don't do a credible review. And by credible review, I mean some of the things I frequently get is there are ratings only and no explanation. Well, I don't know whether you've understood it or not. That's not told the presenters anything, and so that's not worth anything. Or somebody said, it's terrible, 1. Everything's a 1 out of 5. And there's no reasonable explanation about why it's 1. I mean, it could well be that it should be a 1, but give a good explanation about why it's 1. And similarly, more often the case is maybe it's their friend who's doing the presentation, but 5. Oh, it's clearly excellent. Yes, why is it excellent? If you can't explain that, well, I have to conclude you don't know what you're talking about, and so therefore you don't get any marks. So despite those warnings, the peer reviews do work well. The amount and quality of comments that get fed back to each team is quite extraordinary, and a great deal more than it could be if I was marking everybody's work. So it works well. It also is a great deal of fun. You learn a lot because you're actually having a discussion. It's fairly informal, and you learn a lot from ideas that somebody, just arise in the discussion. So it's good. I've used it in several subjects, and as I say, it works well. The exam, there is going to be an exam. This is an undergraduate subject, so there will be an exam. It is a 2-hour exam, and it will. It used to be 3 hours, and it used to have a multiple choice or short answer section. So that short answer has been taken out because that's merely exercising your memory, and that's not useful. What's left will be 2 questions. The first one will be where I give you an architecture that may be suboptimal or have a mistake in it, and you will be asked to critique that and to correct it. Okay, so that will exercise your understanding of an architecture, and your reasoning about an architecture, and your ability to develop an architecture. The second question will be, here's a problem, design me a architecture, possibly an execution architecture for that particular thing. It's only, it is not the full context and conceptual and all the rest of it. It's just simply one architecture. As I say, more than likely the execution architecture, because that usually is enough to show whether you understood it or not. Now, in last year's exam, it became very evident, 2 things became very evident. One was that a lot of people knew they had enough marks to pass without doing particularly much. So they just simply didn't attempt much in the exam. So this year, you will have to be able to draw an architecture, and that will happen through the tutorials and in the exam. If you can't draw an architecture, an execution architecture, then you probably won't do very well. So please learn how to draw an architecture. Now the question comes up, how do we get good marks? It's usually not a problem for people who do get good marks, but for people who are on the edges of pass-fail, it's probably a mystery. It's not hard. To get good marks, turn up. Come to tutorials, engage in the discussions, do the quizzes, do the team project, and participate in the reviews quite actively. It's not hard to pass. And it's not hard to get a good mark if you do all that.